Good afternoon. Welcome back to the demo zone presented by Composites One and the Closed Mold Alliance, doing another infusion process with a reusable silicone vacuum bag. We already have all the dry reinforcements loaded into our boat hull. We're not using a gel coat, but in normal production we would be. Before we load all our materials, before we spray our gel coat, we need to make sure the mold is properly prepared so that our part will release and we'll have good cosmetics and we won't damage our mold.
For the mold, we've talked earlier, we have a sealer on here, Chemly Sealer 15EZ, and then our PMR 90EZ, and you can see the nice gloss you have on the flange, and this will give you multiple releases. But with vacuum infusion bags, when you have a silicone bag, nothing's supposed to stick to silicone, right? But you can occasionally get resin sticking to your bag, and then you're having to chip it off before you can do another cycle. And so what we recommend to prolong the life of your silicone or reusable bags, latex, is to coat it with whatever release you're using. You don't need a special release. Any semi-permanent release will do.
So now, after we've prepared our mold and we've prepared our bag, it's time to load it. So this one is already loaded, but we're going to talk a little bit about the reinforcements and core materials that we have in this boat today. So I want to introduce Russell Elkin from 3A to talk about some of the products available for infusion molding.
Thanks, James. Good afternoon. My name is Russ Elkin. I'm the Product Development Manager for 3A Core Materials. We have a very broad selection of core materials for multiple markets. So today, I'm going to talk about the materials we have specifically for the marine industry. Generally, our Baltec balsa is widely used, very economical product. Or our AirX foams. Typically, those are our AirX T92, C70, and PX products. And the idea that we sell is really the right tool for the right job. Specifically in a boat hull, you have very different requirements for each area. You have specific requirements for the hull bottom, specific requirements for the hull sides, for the transom, for the stringers, bulkheads, deck, etc. And we offer different materials for each specific part to give you the best value for your money and the best performance for the weight.
So, Russell had just talked about the core materials and how they're combined with the VectorPly products. So I want to introduce Mike Ditzler from VectorPly to talk about some of the reinforcements that we're using today.
Thanks, James. Thanks, Russell. My name is Mike Ditzler. I'm Southeast Region Sales Manager for VectorPly. VectorPly is a manufacturer of non-crimped, stitched, multi-axial reinforcements. We make a lot of materials out of fiberglass, aramid, as well as carbon fiber materials as well. Along the lines with what Russell was saying, in response to our customers' requests that we help them reduce and minimize the amount of labor that goes into producing their parts, we went through a product development process where we tried to combine as many layers of material as possible to help reduce the labor and help increase reduce production time, increase production rate for our customers. Those materials that were born out of that are lovingly called our peanut butter products, or our print blocking materials. And the first one we've got here is our ELT CFM PB 120310. So what this material is basically after the finish mat, this is a combination material that consists of a 1 ounce continuous filament mat, along with the Soric TF print blocking material, and a 12 ounce 090 product. This material maintains its conformability and it's multiple layers stitched together. So instead of having to put down 3-4 layers before core and then core down and put more materials, it just comes off the roll. It can be cut to net shape in a kit form. It lays onto the hull side, still conformable, goes on easily, and really helps reduce the labor.
Thanks, Mike. Yeah, I've worked with Mike and Russell on several different projects, and I can really attest to the labor savings. You can see there's several different materials combined into one product, very easy to install. Perry Peterson from Canada is going to tell you about how we made the bag, some of the features in it, and how you might go about making a reusable silicone vacuum bag. Perry?
Thank you, James. This is a platinum grade silicone. It's a spray-on system that we use. What's really nice about it, there's no real smell to it when you manufacture the bag. It's very quick to do. Fairly simple process. If you have existing tooling, we would basically create the cavity thickness either with a finished part or a sheet wax, whatever you have. And what we would do is put that in there to give us that cavity thickness. So once we spray up the bag, you're leaving the cavity to replace with your layup materials. What we'll do now is we'll pull the vacuum. We've got our vent tabs communicating here. If we didn't have that communicating in here, we wouldn't be able to create the vacuum. So once the vacuum is sealed on this outside perimeter, it's going to tell this to pull all the cavity tight.
I'll hand it off to Drew Simmons from MVP.
Thanks, James. So today we are using our Innovator 2 injection system. So this is set up for injecting vinyl ester or polyester resins. So I'm going to go ahead and hit recirc. What this is going to do is just going to get all the material flowing back into your drum of resin, recirc your catalyst back into your jug. When we're ready, we've got our stroke counter right here. That way we can set exactly how many strokes of resin we want to put catalyzed resin into the part. That way your operator can set it, hit inject, walk away, do something else, load the next part, demold the last part, and then the pump will shut off when it's reached its stroke count.
And while we're starting the injection, I'll let Rick Power tell you a little bit about the resin that we're using today.
You've obviously seen 3 processes. This is the 3rd out of the same mold, which is kind of exciting. So you saw vacuum infusion. Yesterday you saw the hard RTM part over here. That was in there earlier today. And of course now the silicone bag, which is kind of exciting. Now the most important part of all of this, of course, is the resin that glues it all together. Which is what we're going to be talking about here. So what we're using here is our Stipol RLPH 0922 resin. It's a very low viscosity for fast mold fill times. All of our products are tunable as well. And different types of catalyst systems can be used, different types of gel times on the material. This particular material that we're running is about 15-minute gel time. We drop the catalyst level down to about 1.25% as well. It's an orthophthalic DCPD resin. Gives us good surface, gives us good color at the same time. It can be pigmented, which is what we've done here. We've put a little bit of black pigment into it, and it allows the material to be seen as it flows.
So now we're watching the resin infuse into the part. So we have our infusion strategy here is we have 4 resin ports, and then we're running basically like a little branch feed to help distribute the resin. How long does it take to make one of these silicone bags?
Once everything is set up, we sprayed this bag in about 2 hours.
So when can you demold it, and then when are you able to infuse a part with the
Well,
bag?
ideally you want to let this probably cure overnight, and then you would want to inject, bond in the injection ports. So typically a day and a half, you're ready to go.
So once the part's cured, you want to take the bag off and let it air out, and then it's pretty much clean it up, and it's pretty much ready to go again. So once we're done, we flush the machine, and it's ready to inject another part.